Hi, welcome back to my channel. Today we are discussing about effect of various chemical elements on the steel. First element is carbon. This is an alloying element to strengthen and harden the steel. As it increases strength and hardness, it reduces the ductility and malleability, making the metal more prone to brittle fracture and also decreases the weldability and corrosion resistance also. Therefore, always every specification says the carbon content should be as low as possible. Second element is manganese. This is also an alloying element in the steel. It improves the strength and hardness and also the toughness. What it does in the steel, number one, it significantly increases the strength, hardness and toughness of the steel by forming strong bonds with iron in stabilizing its crystal structure. It removes the impurities like sulfur and oxygen, leading to stronger, less brittle metal. It enhances the hardenability of the steel, making it easier to harden and increase its wear resistance. Also, it forms manganese sulfide, which improve the machining quality of the steel. What does it do in stainless steel? Manganese improves ductility in stainless steel. It also increases the solubility of nitrogen in austenitic steels, allowing for higher nitrogen content. Next chemical element in the steel is phosphorus. Phosphorus, phosphorus is a notorious young brittling agent, particularly in the steels. It can segregate to grain boundaries, a phenomenon known as a temper embrittlement, which significantly reduces toughness and the material's ability to resist fracture during process or in the service. It also decreases the ductility, making the metal more prone to cracking and breaking. It tends to migrate to grain boundary during continuous casting and cooling, which can worsen the mechanical properties of high strength product like pipes or pressure vessel plates. In stainless steel, high phosphorus content can lead to decreased corrosion resistance, making it a controlled impurity. In some high manganese austenitic steels, it can segregate at grain boundaries and form a low melting point eclectic phase, hindering thermoplastic processing. Despite its general detrimental effects, high phosphorus in supermartensitic steel, stainless steel, can sometimes increase impact toughness and improve resistance to pitting corrosion. This pitting corrosion property, resistance to pitting corrosion property is very important. Our fourth chemical element is sulfur. What it do in the sulfur? Sulfur forms a iron sulfide, which segregate at grain boundaries and causes brittleness, which is also called hot shortness. This, these cracks during rolling and forging, and severe loss of impact toughness, particularly in the transverse direction, transverse direction of rolling, like rolling plate or rolling sections. Even small manganese sulfide inclusion drastically lower impact properties in transfer direction. Sulfur enhances the machinability but decreases the transverse ductility and not impact toughness, and has a nominal effect on longitudinal mechanical properties, but transverse, yes, transverse ductility will reduce. The sulfur's content of steel in amount exceeding 0.05% tend to cause brittleness and reduce weldability. In some of the material, sulfur kept from 0.1 to 0.3%, which improves machinability in so-called pre-machining steel or pre-sulfurized steels. This enabling easier cutting and tool life extension for manufacturing. Such steels are intentionally alloyed with elevated sulfur for application where superior machinability is required. Steels with sulfur above 0.05% reduces the weldability and promotes hot cracking during welding. This is very important. That's why sulfur should be 0.05% if you are going to weld the steel. When sulfur is when sulfur is added to iron, what it does, it it form a iron sulfide. Also, it forms some manganese sulfide. Sulfide inclusion created by sulfur act as corrosion initiation site, which reduces the steel's resistance to environmental attack and reduces the fatigue also. Sulfur decreases the transverse ductility, but sulfur have very little effect on longitudinal mechanical properties. And this is the reason some of the specification or uh, most of the specification says that we should take the tensile test specimen in longitudinal direction, not transfer direction. After sulfur, next element is silicon. It improves the tensile strength and elastic limit of the steel. Also, it enhances fatigue and shock resistance, improves corrosion, wear resistance. In steel making process, we add silicon to remove oxygen, which improves the quality and soundness of the steel. High silicon content can lead to poor surface quality and aggravate cracking tendencies in the steel. If we want to galvanize such steels with high silicon, then it will lead to thick, dark and dull galvanized coating of the steel. Next element is chromium. This is very important element. Chromium forms a protective oxide layer on steel which significantly resists rust and corrosion, especially at the content above 10.5%. Chromium forms a oxide layer known as a passive film, is thin but significantly slow down corrosion rate. Chromium enhances oxidation resistance at high temperature, this making the steel suitable for high temperature services. This property is very important. The addition of chromium improves the tensile strength and yield strength. Approximately 1% of chromium increases the tensile strength by roughly 8 to 100 newtons per millimeter square. Chromium also improves hardenability, wear resistance, and response to heat treatment. Chromium can increase toughness and hardness, and steel with higher chromium, usually 14% and above, are referred to stainless steel for their rust and stain resistance. Chromium also has a grain refining effect, making steel more uniform in structure. When chromium mixes with the carbon, it forms the carbides. This will help in wear resistance and strength of the steel. Chromium also increases the heat resistance and allows for the steel to withstand high temperature services. Now next element is nickel. Nickel is a very important element in stainless steel and it is also very important where low temperature service environment is there. So we'll see what it do. Nickel increases the toughness and impact strength of the steel, particularly at sub-zero temperature, without reducing its ductility. It raises the elastic limit, tensile strength, hardness, making steel more resilient to fatigue and shock. Nickel enhances corrosion resistance, especially when combined with chromium, making stainless steel both rust and oxidation resistant. It helps in resisting scaling at high temperature and improves the steel's resistance to both acidic and marine environments. Also, nickel contributes to improved formability, weldability, and ductility in the steel. Last chemical element is nitrogen, which is very important role in the steel. What it does, nitrogen acts as a solid solution strengthener, raising both yield and tensile strength of the steel. It boosts hardness, improve fatigue resistance, particularly in austenitic and duplex stainless steels. Nitrogen refines the grain structure. This is very important property of the nitrogen. It improves the grain structure, improving its strength and wear resistance, but high level can lead to brittle or strain aging. In certain stainless steel, nitrogen increases the resistance to localized corrosion such as pitting and crevice corrosion. By influencing the distribution of carbides and forming nitrides, this enhances the passive film for better corrosion resistance in aggressive environments. Also, high nitrogen content can adversely affect weldability, leading to embrittlement, especially in the heat affected zone. Throughout this effect of various chemical elements on steel, we have come across various mechanical properties. To know more about mechanical properties, please refer to the video which is in the description below. Also, I am attaching this effect of various chemical element on steel's PDF in description below. You can download it for your use. In this video, we have covered only 8 elements. If you want to know any other element, please ask me in the comment. I'll try to explain those also. My next video will be on ASTM material. If you find the content of my videos are useful for you, please share, like, and subscribe my channel. Thank you very much.